Okay, so continuing where we left off, we're going to look at running and kind of talk about some of the different concepts related to running that create some slightly different things from obviously the regular walking gait. Some of this we kind of already looked at in lab, but we're just going to kind of explore it a little bit further. So the first thing we're going to look at is there are various types of running. So in essentially, when you're talking the language in regards to this, running versus sprinting. So running is running at a little bit more submaximal pace. You're obviously moving faster than you would be with walking, whereas sprinting is kind of running at full speed for a very short distance. And there is some slight differences in what happens. We'll kind of mention some of the changes that occur. But the general differences we're going to look at as far as the walking gait as opposed to running or basically picking up your speed is the changes that occur from a center of mass standpoint and what that means as far as the different phases of the running gait, the ground reaction forces, which we know are obviously going to increase, and some of the characteristics that going to change, and we're going to mention the spatial and temporal characteristics. So the biggest differences as far as running versus walking. During the running phase, there's no double support phase. Instead of having a double support phase, you have a double float phase. There's much greater range of motion in the running gait. You have a greater swing phase. So we had mentioned during the walking gait, the split is 60% stance, 40% swing approximately. In the running gait, that kind of switches, particularly the faster you run, so the swing phase becomes more dominant, and you have much greater eccentric activity because of the deceleration forces required to stop the limb while you're running. Okay, so in looking at the phases, now we have phases with running just as we do with walking, and they're going to still be broken up in the two general phases as far as stance and swing. The biggest difference is going to be the phases within the stance and swing phase. So, for instance, in the stance phase, instead of having the phases that we have during the walking gait, heel strike, foot flat, mid stance, heel off, toe off, you're now going to have just what's called an absorption phase, which is basically the initial contact, which is usually depending on how you're running. If you're running submaximally, you're still usually going to be on the lateral heel. Is basically going to be initial contact until mid stance, and the purpose of that is to absorb force. And then you have a propulsion phase, which is when the center of mass comes over the weight-bearing foot until the heel lifts, and then that begins the first double float. Okay, so those are the two phases you have during the stance phase. During the swing phase, you have an initial swing, and that's at the beginning of the double float. The hip and knee flexion starts to increase, along with ankle dorsiflexion and hip abduction. And then you have the terminal swing, which is basically as the limb is starting to accelerate and then starts to decelerate. Okay, so the biggest thing during the terminal swing phase is going to be the limb deceleration. And again, that's where those high eccentric forces are going to come in to be able to decelerate the limb. And obviously, those forces become much greater as the speed of running increases. Okay, so in looking at the kinematics, we're going to break down the kinematics very similar to the way we did as far as the walking gait was concerned. So we're start going to look at the sagittal plane and look at what goes on at the trunk and pelvis. So at the trunk and pelvis, the biggest changes that are going to occur is you're going to get an increased forward trunk lean, particularly during the acceleration phase in sprinting. So, some of you have taken the strength conditioning courses, and we've talked about sprinting with the acceleration phase versus max velocity. In either case, the trunk lean does increase. It increases much more with acceleration. And the other thing is the faster someone moves, their center of mass also tends to be held a lot lower, and that's just going to make for greater efficiency when they're running. There's also greater overall anterior tilting in the pelvis as opposed to the walking gait. So the pelvis tilts anteriorly much more during the running gait. As far as the hip is concerned, the biggest thing is the hip extension that occurs much later. As during the last part of the terminal swing, the hip begins to move towards extension, and that's basically again to help with that center of mass. So it helps keeps the center of mass much lower while the individual is running. The knee, basically, the biggest thing about the knee is there's just greater range of motion. So the extremes of motion are much greater. And then as we get to the ankle and foot, there's more dorsiflexion of the ankle and there's much greater activity of the gastrocnemius muscle. So you think about the ankle basically almost acting like a spring. So there's greater ankle dorsiflexion, which is going to allow for the stretch reflex in the gastroc to occur at a much greater rate, which is obviously going to help with the speed of the running. Okay, continuing on with the kinematics, if we look at the frontal plane, so again, we'll start at the trunk and pelvis and note the highlights here. So the trunk in the frontal plane is going to lean more to the weight-bearing leg, more so than it does during the walking gait. It's also going to kind of remain very high on the stance leg, particularly at initial contact. So it's going to be much higher than it would be during the walking gait. As you get into mid-stance, the pelvis is actually going to move downward on the stance side leg. Okay, so the pelvis will move downward on the stance side leg, which kind of changes up some of the dynamics from the walking gait. On the hip, so the hip is going to be actually adducted on initial contact, and then at mid stance, you're going to have hip abduction until mid swing, and then you're going to get greater adduction. So again, compare this to what goes on during the walking gait, and again, some of this is just to allow for greater limb motion and the balance that has to happen, because as you start to go faster and faster, as the speed of your gait increases, the foot tends to come more towards the midline. So that's what's going to impact a lot of these frontal plane characteristics. At the knee, at contact, it's going to be abducted, abducted, and move into adduction by mid-stance. And then during the propulsive phase, the knee is going to be basically abducting the entire time. The ankle and foot are basically going to do the same things for the most part during the walking gait. Again, it's just going to happen much faster and a little bit greater range of motion. So the ankle and foot complex is basically going to move from inversion to eversion and back to inversion during the weight bearing part of the running gait. Okay, so looking at the kinematics now in the transverse plane, so the trunk and pelvis does some unique things different from what you get in the walking gait. So the lower spine is going to rotate backwards with extension of the lower extremity. The upper part of the spine is going to do the opposite, and this is part of the reason why the arm motion is so important to kind of counterbalance what's going to go on at this area. The other thing to note is the pelvis is actually going to do the exact opposite of what occurs with walking. So if you looked at the walking gait, as you're kind of bringing your leg through to initial contact, the pelvis protracts. It's going to do the opposite with running. And some of this is going to have to do with kind of the power transfer and everything that you get through the extremity. So the pelvis kind of does the exact opposite motion of what occurs with the walking gait. With the hip, at absorption, it's going to be medially rotated, and it's going to laterally rotate to meet neutral just prior to toe off, which is going to allow for that greater increase in activity to take place. At the knee will be laterally rotated at initial contact and will move to medial rotation throughout the stance phase. And then at the ankle and foot, we look at, again, pronation and supination, and we look at what's going to happen with absorption versus propulsion. So during the absorption part, the ankle is going to be looking to move into pronation, and that's obviously so that you can adapt to the ground. The propulsion phase would begin to supinate, because that's going to create the rigid lever to be able to push off as you're going through the gait cycle. Okay, so we had mentioned at the beginning of this that there's a distinct difference when you talk about speed progression. So you have walking, running, sprinting. Obviously, when we're talking about sprinting, we're talking about running it at the maximal speed possible for a short amount of time. So just to kind of summarize kind of the progression that occurs at each one of these areas, the trunk, hip, knee, ankle, and foot. So the kind of the biggest the characteristics that kind of jump out the most. So at the trunk, the biggest thing is increased forward lean and overall increased anterior tilt of the pelvis. At the hip, you're looking at increased degrees of hip flexion. So the hip flexion becomes much greater when you're talking about increasing the speeds. Obviously, as you get to sprinting, that's going to be the largest amount of hip flexion. With the knee, the swing phase, the knee flexion increases again the faster you begin to move in the gait. The ankle and foot at initial contact. So in sprinting, the heel may never touch the ground. So typically, the faster you start to run, you start to strike more on the midfoot to forefoot region as you start to go faster and faster. So during sprinting versus running, so when you're running submaximally, you're going to be still kind of striking on the heel. When you're sprinting, the heel will likely not touch the ground. Another thing to look at is the important things is the faster that you're moving. During the swing phase, we talked about the knee and hip motion, and that's basically to allow for ground clearance to occur, and you're still going to get a lot of increased dorsiflexion. And the reason why you're going to get the increased dorsiflexion is for that spring action that's going to have to occur at your lower extremity. And when we're talking about muscle activity, you're going to get increased quad and calf action simultaneously to deal with the increase in forces that are going to occur while you're running. Okay, so we're going to talk a little bit about the muscle activity as the running gait starts to occur. Now, again, make sure, as I talked about in lab, I gave you guys that chart to be able to look at the muscle actions during walking. Here, I'm just going to kind of summarize some of the small differences that occur with running versus walking. So we'll talk about the hip muscles first. The glute max, as far as timing and everything, basically works the same way regardless of speed. Obviously, the biggest difference is going to be the amount of force that the glute max will produce during running. But as far as timing and everything, it pretty much acts the same. The glute medius has overall increased activity with speed, and that's just to help kind of balance the pelvis. If you think about those frontal plane motions that we described earlier, and how the glute med would have to increase its activity with that. The hip flexors are going to work harder to decelerate hip extension prior to the swing. So you have, the forces coming through at a large rate during the absorption and propulsion phases. So the hip flexors are going to have to really work hard to decelerate that hip extension prior to the swing. The hamstring muscles, which we kind of discussed this already in class. So the important thing to know about the hamstrings is they're primarily active at the hip. The knee flexion that occurs with running, again, has more to do with the dynamic coupling that's going to occur from the hip and ankle motions. So the hamstrings, as far as a force producer, are going to be primarily active at the hip. They're going to work to decelerate the lower leg during the terminal swing phase, but for the most part, their activity is going to be at the hip. The adductors are going to be needed for greater stabilization during the stance phase, so they will be having a high level of eccentric activity. And the other thing they will be doing is during the swing phase, looking to kind of bring the femur to the midline. So those are some of some of the slight differences you have as far as the hip muscles. At the knee, you're going to have much longer quadricep activity, so the quad is going to be active for a much longer period of time, and particularly the rectus femoris. So the rectus femoris is going to be having to work a lot harder because it's going to be doing some different things at both the hip and the knee. So it's going to create greater hip flexion to lower the center of mass, and it's also going to be at the same time looking to control the amount of knee flexion with the center of mass posterior to the knee. So as the center of the mass kind of gets posterior to the knee, the rectus femoris is going to have to work a lot harder to kind of control the amount of knee flexion that's going to occur with that. And then we look at the ankle and foot. So this is actually where the greatest amount of changes take place. There's much greater activity and forces at the gastroc-soleus. So the stretch reflex is going to be working a lot harder. Again, the ankle and foot more or less acts like a spring during the running and sprinting. The textbook talks about having to absorb 250% of your body weight, and a lot of sources even kind of cite higher amounts of forces related to that. The tib anterior in particular is going to work concentrically after the initial contact to stabilize the foot and help accelerate the tibia. And during pronation, there's going to be increased eccentric activity of the tib posterior and gastroc-soleus, again, just to control motion. Okay, so there's going to be a lot of forces. So of all of the areas, the greatest amount of changes as far as force production, motion, force absorption is going to occur at the ankle and foot. Okay, so keeping with the kinetics of running as far as the forces and some of the different things that are occurring. So again, the look at the internal forces. So there's a much greater forces being produced during running. The body's having to both absorb a lot of forces and create forces in order to move as fast as needed. So the primary element here is going to be mechanical power. So, and strength contributes to that, but again, it's important to note the difference between strength and power. So strength is just the ability to produce force. Power is kind of time-dependent force, and that's really the primary element as far as success with running is going to occur. As far as what are the most important muscles, we look at the different parts of the running gait. The hip extensor muscles, particularly during the late swing and early stance phase, are very important. The hip flexors during the swing phase, so the hip flexors have to move very forcefully to bring the entire lower extremity through the swing phase. And then the quads, glute medius, and plantar flexors during the stance phase. So those are the kind of the important muscles and kind of where they occur during the different parts of the running gait. Again, the stretch shortening cycle, and this is going to be very active at the ankle and foot complex in particular. I mean, there's increased load throughout the entire lower extremity, but the ankle and foot kind of take on most of this. So there's going to be an increased tendon load with this, because as we know, the stretch shortening cycle will utilize the tendon and other connective tissue beyond the active muscular contractile components to be able to produce this. And an important thing is the role of the upper limbs. So I don't really like the way your textbook talks about this, because they talk about the upper limbs and they're not sure if there's a role. There definitely is a role to the upper limbs with running, more particular to counterbalance the rotation, which we had talked about earlier, particularly at the spine and pelvis. So that allows for just that force transfer and greater efficiency while you're actually running. And then we look at the ground reaction forces. So the ground reaction forces obviously become much greater with running, and in particularly the faster you begin to run. So the foot contacts the ground. Remember, the ground is going to produce force back. That's going to be Newton's third law. And the greatest forces that occur are going to be your downward forces. And the propulsive phase has a really big impact on your ability to run fast. So those downward forces are going to be significantly great. Again, they're going to increase, the amount of forces that are going to increase there are significant compared to the walking gait. And again, the propulsive phase is going to have the greatest impact as far as your speed of running, because that's what's basically getting you off the ground. The important thing is your body has to be able to absorb that force when your foot's coming down. So again, that's what makes mechanical power so relevant to running. So again, you have to have a certain degree of strength, but then you have to be able to display it as fast as possible. And these are your learning outcomes. So again, make sure that you're kind of looking at the muscle actions. Again, take your time and review. Use some of the tables also as well. I mean, I kind of mentioned highlights of things to kind of note here. Remember, I gave you that chart in lab as well. So be sure to look at the anatomy associated with the walking gait.